In this section, we will be discussing modeling with linear functions. So we're just going to go over a couple of application problems that involve linear functions. Of course, there are so many variations of these, so I can't cover everything that you could possibly see, but these are some that hopefully will give you a base to kind of refer to as you work through some of these in your homework. So this corresponds to the free OpenStax textbook, College Algebra. You can find it at the website that's listed throughout the presentation. So it corresponds to section 4.2. So the very first question that we have here, a city's population has been growing linearly. In 2008, the population was 28,200. By 2012, the population was 36,800. Assume this trend continues. So we're going to predict the population in 2014, identify the year in which the population will reach 54,000, and that's all for that problem. So before we can do those things, we need to write an equation. So in order to have a linear equation, we need to have a slope. So we can find the slope using the information given. So in 2008, the population was 28,200. So that can be an ordered pair. In 2012, the population was 36,800. So both of those will act as ordered pairs. And so now we can find a slope. So we can do 36,800 minus 28,200, and that's from 2012 to 2008. So that's just the slope formula. So if we subtract, we have 36,800 minus 28,200, we get 8,600 over 2012 minus 2008 is a 4-year period. And then we divide that and we get 2150, so 2,150. So this is the slope. What is the slope? Remember, the slope is the rate of change. So this is saying that every year that passes, the city's population grows by 2,150 people. So this is people per year. That's how we set this up. So that is the rate of change. So we're going to assume that rate continues. Predict the population in 2014. So in order to do that, again, we have to have an equation. We've got the slope. Now, the first year that we have given to us is 2008. So we can assume that this is the base year. So the base year started with 28,200. So that's the starting value. That can be our intercept, and then it increases by that every year by the slope. So our equation will be y equals 2,150 is the slope times x. X is the year plus, or the number of years since the base year, we should say. And then plus the base year's population is 28,200. Okay? So we start with a population of 28,200. That's why we have this. We start here, and then every year that passes, we get this many more people per year. So X is the number of years since the base year, which is 2008. That's what X represents. And then Y would represent the population at whatever year you're looking at. So you need to know what your information represents in your equation. So now that we have that, we can use that equation to complete parts A and B. So for part A, predict the population in 2014. So 2014 is the year. X stands for the number of years since 2008. So you don't just put 2014 in for X. you want to calculate how many years it's been since 2008. So you subtract. So 2014 minus 2008 is 6. So it's been 6 years. So that's what x will be. So you have y equals 2,150 times 6 plus 28,200. And let's see, when you do that, 2,150 times 6 is 12,900. And then you add that to the 28,200 and you get 41,100. So your prediction for the population in 2014 would be 41,400 people. Okay. And so now in part B, identify the year in which the population will reach 54,000. So now we're given a population. Well, the population is Y. So we're going to plug that value in for Y. So that will be 54,000 is equal to 2,150x plus 28,200. And so now we want to solve for x. So in order to solve for x, the first thing we're going to do is subtract 28,200. And let's see, 54,000 minus 28,200 is 25,800. And then the next thing we want to do is divide by 2,150. So that'll give us x equals 12. So x is 12. What does that mean? That says identify the year. So that's not the year, right? So this means, remember, x stands for the number of years after the base year, which is 2008. So you have to figure out what year will it be 12 years after 2008. So you add those together and you get 2020. So you predict that their population will reach 54,000 in the year 2020. Okay, so let's look at the next example. The next example, a phone company has a monthly cellular plan where a customer pays a flat monthly fee and then a certain amount of money per minute used on the phone. If a customer uses 410 minutes, the monthly cost will be $71.50. If the customer uses 720 minutes, the monthly cost will be $118. Okay, so similar to the last one, we're going to have to use the information given to find an equation. So first we want to start with finding a slope. So we can find a slope. We have 410 minutes corresponds to 7150 and 720 minutes corresponds to 118. So to find the slope, we can have dollars per minute. So 7150. Well, I guess it makes more sense to do it the other way. You can do it this way and the two negatives will cancel out. But let's go ahead and do 118 minus 7150 over 720 minus 410. All right, so if we do that, 118 minus 7150 is $46.50 over 720 minus 410 is 310, and so we're going to divide that. So 46.50 divided by 310 gives us 0.15. Okay, so let's think about what that means. The top is dollars, the bottom is minutes. So this is dollars per minute, okay? So that means the cost is 15 cents per minute That's the variable cost, right? That's the amount that changes depending on how many minutes you use. Now, it told you in the beginning there is a flat fee and a variable cost, an amount per minute. So let's figure out, we have 410 minutes, costs $71.50. So if we're being charged 15 cents a minute, let's see how much this is. 15 cents times 410 minutes is $61.50. So to find the flat fee, we can subtract these. So $71.50 minus $61.50 is $10. So that's the flat fee that you're being charged. We could do the same thing with the 720 minutes. If we did 720 times 15 cents a minute, we would see that that is $108. And the difference between 118 and 108 is 10. So again, the flat fee is $10. Whenever you're dealing with a linear equation, so our linear equation, y equals mx plus b. Your variable cost is your slope, because this varies according to how much you use it or what you have going on. It varies by the variable. So that's the variable cost or the variable amount. B is the fixed cost or fixed amount, because it doesn't vary. That's how much everyone pays no matter what. So that's where your variable cost and your fixed cost go. So in this case, our variable cost is 15 cents. So 15 cents, it varies depending on the number of minutes you use, plus your fixed cost is $10. So even if you use no minutes at all, if you do not even use your phone, you're still paying $10. So this is our equation. Okay, so that is the equation. Another way we could have written it, since it said find our linear equation for the monthly cost as a function of x, you could have also written it as a cost function. You'll see that a lot in business, but it's the same thing. Okay, and then for part B, so that's what it asks us to do. Part B, interpret the slope and the y-intercept of the equation. So they want you to explain what those things mean. So we've talked about that. Let's write it out. So the slope of 0.15 means that the customer will pay 15 cents per minute. Okay, and then the y-intercept of 10 means there is a flat fee of $10 per month that all customers must pay. Okay? And then part C, use your equation to find the total monthly cost if 687 minutes are used. So you have two variables, you have y and you have x. You have to remember which one is which. So the x stands for the number of minutes used, while the y stands for the cost. So they're giving us the minutes, so we're going to plug that in for x. So we're going to use our equation, y equals 0.15 times x, which is 687 in this case, plus 10. And so if we do that, we're going to multiply 0.15 times 687 and we get 103.05 plus 10. And if we add those together, we will see that we get $113.05 as our total monthly cost if you use 687 minutes. All right, number 3. A company sells donuts. They incur a fixed cost of $25,000 for rent. So here it's telling you this is the fixed cost. That means they're telling you the Y-intercept. It costs 25 cents to produce each donut. So 25 cents is a cost based on an amount. So it varies, right? So this is your variable cost based on how many donuts you produce. So this is your slope. So that being said, we can easily write this equation. Write a linear model to represent the cost C of the company as a function of X. So we want to write it as a function. So we're going to write C of X equals the variable cost, so 25 cents per donut, plus a fixed cost of $25,000. So there's our equation. So this one was actually easier than the other two because here they gave us the information. As long as you know where to put it, that's the key here. Okay, so now let's see part B is find and interpret the Y-intercept. Okay, well that was given to us, right? I mean, it didn't say Y-intercept, but if you know that that's the fixed cost, then you know that that's what it is. So the Y-intercept is the fixed cost, which in this case is $25,000. So the company has to pay this amount I think it said each month, right? Well, it didn't say, so we'll say for each month. The company has to pay this amount. We'll just say this amount regardless of the number of donuts. Produced. So if something happens and he is unable to produce any donuts, it doesn't matter if he never steps foot in the building, he still has to pay that $25,000. So it's a fixed cost. Okay, and number 4, this will be our final example for this section. The insurance premium charged by a home insurance company is proportional to the home's value. For a $150,000 home, the monthly premium is $95. If a customer is paying $145 per month for their homeowner's insurance, what is the value of the home to the nearest dollar? So a proportion, it says it's proportional. A proportion is when you set two fractions equal to each other. So for example, $150,000 home, you pay $95 for the premium. So we're doing home value on top, and we're doing the monthly premium on bottom. You have to keep that relationship the same for your equation. So the other side, we don't know the home value, so that's going to be X, but we do know that the premium is $145 a month. Once you have your proportion set up, you're going to simply cross multiply and make an equation with that. So you'll have 95 times X, so 95X equals 150,000 times 145. So that's 21,750,000. And then to solve that equation, you're simply going to divide both sides by 95. And so then you will have x equals 228,000, comma, $947, and then I get 0.368. So I'm just writing everything down that I see on my screen, on my calculator, and let's talk about how to round this. So it says to round to the nearest dollar. So make sure you round appropriately. That means I want my number to have this many digits. So I need to use this number to round. So since it's a 3, it's going to stay the same. So you round down by getting rid of that. So your answer would be $228,947. That would be to the nearest dollar. Remember, in order to round up, this 3 would need to be a 5 or greater. So if it's between a 0 and 4, you keep the number the same. In other words, round down. If it's between a 5 and a 9, you round up. All right.